Thanks for joining our session today. I'm Ryan Loney. I'm a product manager at Intel for OpenVINO. And the best part about my job is getting to work with our partners and customers who are building solutions that use OpenVINO for inference. And today I'm fortunate to be joined by George Shaw, who's the CEO of Pathr.ai. Pathr is they've built a spatial intelligence platform that's used by retailers for doing things like loss prevention and heat maps to better analysis or spatial intelligence in retail scenarios. So, George, why don't you tell us a little bit about spatial intelligence and how Pathr is using OpenVINO?
Yeah, will do. Thank you, Ryan. Appreciate that, and appreciate the Intel team having us here at DevCon. I'm really excited to talk about what Pathr's doing in spatial intelligence. I'll put spatial intelligence into the context of computer vision and sort of the history of computer vision and where we are currently and how right now is exactly the right time to do spatial intelligence. We'll talk about some of the areas where spatial intelligence is being applied outside of retail, and then I'll focus on how Pathr is applying spatial intelligence to retail and what some of the benefits that we're getting from leveraging OpenVINO in order to do that. And so with that, I'm going to start with an intro to spatial intelligence, just sort of what it is. So spatial intelligence is the tracking of people in physical spaces and then understanding that tracking from the perspective of the operators of those physical spaces. So that tracking can be done in any number of different ways. Today, we'll focus specifically on computer vision-based tracking, but there are ways to track folks wirelessly. There are lots of other solutions to understand where people are in physical spaces. All of those are spatial intelligence. But then where the real sort of strategic focus is what do you do with that tracking? And how do you make that the tracking of people valuable to business operators? And so that's where we'll spend some time today discovering what Pathr's doing in that regard. The visualization that you're seeing here is really the simplest sort of spatial intelligence that you can possibly do, tracking people as they move through in this case, a small specialty retailer, and then pulling out things like how many people pass by a particular location and how long do they spend at any one location. We'll get into some more sophisticated use cases later on in the talk. So to start with, I want to put spatial intelligence in the context of the history of computer vision and more specifically the history of artificial intelligence as a whole. Artificial intelligence began in 1956. This is when the term was coined. Marvin Minsky, John McCarthy, and Claude Shannon at the Dartmouth conference. This was the very first time anybody had heard the term artificial intelligence. This was sort of the birth of AI, was in 1956. One thing that you'll notice on this timeline is almost immediately after people said, let's make computers smarter, they said, let's help them to see. Computer vision was really one of the very first things that researchers started to pursue once artificial intelligence came online and became something that folks were interested in. The Huff transform was applied to digital images in 1959. Another thing that you might notice here is there was not a lot of development in computer vision between 1959 and 2012. Now, I'm exaggerating slightly. Of course, there was development, but when I started working in CV in the early 2000s, I was applying Huff transforms to images. There wasn't a huge amount of gain that was made until 2012, when everything changed nearly overnight. And that brings us to now where computer vision is in this commoditization phase in a lot of ways. So let's dig a little bit more deeply into that, see what happened in 2012. So this is the error rates for the winners of the ImageNet classification competition from 2011, when the data set was first formed, up till 2017. What you're not seeing here is that if you looked at 2010, if you looked at 2009, if you looked all the way back, that error rate would be relatively flat. There wasn't a lot of gain. 2011 was the first year that the data set was available and the first year that they actually ran the competition. And so the old way of doing computer vision was producing about 26% error. It was getting about a quarter of the images wrong. This classification competition is about pulling out objects in the images automatically and labeling those objects. This is a cat, this is a hot dog, so on and so forth. But then the following year, Jeff Hinton and some of his students brought to bear the very first production-ready deep learning model called AlexNet. And you can see that the error rate dropped almost in half overnight. From 2011 to 2012, there was a massive change, a huge improvement, nearly doubled the performance in the AI's ability to classify these various objects. And then even more importantly, that error rate kept falling after that. So this is one lens into what we know as the deep learning revolution. I mean, the entire field of computer vision, as well as many other aspects of AI, changed overnight and has continued to improve ever since until present day, when the computer, the AI, can do better than twice as good as a person looking at these images. So this was a new approach. Deep learning wasn't ready for prime time before 2012. Now it is, and that's really changed the landscape in terms of how we see computer vision and how we go and we pursue these sorts of problems. Which brings us to the current day, where the big tech companies like Intel are able to leverage this relatively mature set of algorithms. The mathematics behind deep learning and the approaches are at the point of maturity where Intel can go and build frameworks like OpenVINO around what's happening in deep learning, and chips that are specifically optimized for this stuff. Even more importantly, to be able to optimize the algorithms for existing chips that are even more general purpose. This is all because of the maturity of the technology. 10 years ago, it was brand new. There were no chips that were specifically built to do deep learning efficiently, whereas now there are. Now there are frameworks that are specifically designed to be able to do this sort of thing optimally and efficiently, which drives the cost of compute way down, the developer resources through the roof. If you wanted to go and do some computer vision task back in 2000, you'd first start by enrolling in a master's program and learning a lot of mathematics and learning a lot of computer science, and then you could go and hope to pursue some computer vision. Well, today, the resources available to developers mean that if you want to go do some computer vision task, you can log into an API and start getting results that afternoon. This is an unbelievably fertile landscape for us to be able to pursue these different computer vision tasks. This commoditization is a very, very good thing for companies like Pathr that are wanting to build on top of computer vision. One of the big questions that you might ask, and a question that we have and that we need to answer, though, is, so where do you go from here? Given that a lot of these computer vision algorithms are mature and they're well formed, and they're being optimized by Intel and others, what do you do? Well, I think it's important to look at the most intelligent things around us in order to understand that roadmap, and that's specifically biology. So we can look at what's happening in biology in order to give us some kind of roadmap to understand where we go from here and what it is that we should be building, and what some of the concepts are that we should be integrating into things that we build. So, I talked about that a lot of these algorithms are mature. You can find open source versions of things like person detectors and 3D scene reconstruction and some of these kinds of things. Well, that's all the way over at the left. That's what an alligator does very, very well. This is very primitive brain. The photons go from the alligator's eyes back to visual cortex V1 and V2, or early visual cortex. And the alligator is able to locate its prey, it's able to track its prey, and it's able to attack its prey. The problem is that if you get in front of an alligator, you might get eaten, because alligators are not particularly intelligent. So there's not a lot of reasoning that sits on top of these computer vision, or these, in this case, biological vision primitives. What we want to move towards is something closer to a dog, where a dog is also able to locate objects in a scene. It's able to track those objects. It's able to move towards those objects, but it's able to apply a little bit more reasoning. The dog barks at the UPS guy when he's outside, but he doesn't bark at my wife when she comes home from work. My dog is a little bit smarter than an alligator some of the time. And that's a really important concept for us to think about, is how do we move towards something like a dog brain, knowing that we've got this alligator brain as a very firm, very robust foundation. We want to build on top of that foundation and not build alongside it. We want to build up from there. And then, of course, I don't bark at the UPS guy or my wife when she comes home from work. Humans tend to be even smarter than dogs, and so that again provides a little bit of that roadmap that we're looking for. This is more of a conceptual roadmap. Where do we want to go with this kind of tech? Well, we want to build on top of the alligator brain. We want to build on top of the vision primitives that we have available to us and that are optimized and that are super efficient. And we want to add reasoning over and above that in order to make these systems more valuable. And that's really the strategy of Pathr, is to build on top of those primitives that already exist and to not reinvent the wheel there. So one thing that we might do is to look in other areas. Is anybody doing this today? What I'm describing here is building on top of the existing primitives and adding more reasoning in order to extract greater value. I think a great place to look for this is in sports. In 2011, the NBA started tracking every player in every game. They figured some grand answer to basketball was going to come out the other side. And the reality was that didn't happen. They started producing metrics like how many players were on the court. It was always 10. How far did each player run during a game? And this is a trivia metric that was interesting once and didn't actually provide a lot of ongoing value. It wasn't until two USC professors at the time got their hands on one of the tracking data sets that the NBA had produced and built a machine learning classifier. They trained up a classifier in order to find every pick and roll in the game. This is the most common play in basketball. There's hundreds of them in every professional game. They built this classifier to say that's a pick and roll and that's not. What that is a higher level of reasoning that sits on top of the raw computer vision. And that higher level of reasoning allows a coach to go in and extract data from the game that's powerful and that's valuable in order to be able to go and coach the team more effectively. So anytime LeBron James is coming down the left side and you're down by 3 in the fourth quarter, what do? Well, that coach would love to have a database full of that scenario and every other scenario like it. And so this is what these two USC professors ultimately produced. They formed a company that was called Second Spectrum, which changed the way basketball got played. Every team in the league uses Second Spectrum currently. And what that software, what that platform is ultimately doing is building on top of the alligator brain and adding some of the intelligence of a dog brain and then later a human brain. I worked at Second Spectrum, and one of the things that I did when I was there was to build an automatic highlight reel generator. So we would take in the play information and the various stats that are being produced, those stats being mainly focused on coaches and the players themselves. We would take that in as a feed and then output an automatic highlight reel as well as other enhancements to the game, sort of what you're seeing on the left where there's underlays under the player that are happening live. So we would add that, and that again is an even higher level of reasoning. That's adding this human brain on top of the dog brain, which is all again built on these vision primitives in order to make better sense of the game. And it turns out generating a highlight reel automatically in basketball is difficult. You have to understand the emotional ebbs and flows of the game. You have to understand something about the history, which plays are easy and which are difficult. What's the storyline that the game is undertaking? So it's a challenging problem. But ultimately, when you're done, you're able to enhance the game from the perspective of a fan so that they can better enjoy it. So that then when they're watching a game on TV, they're having more interest in it, and you're bringing in new fans. You're sort of meeting people where they are by adding this additional reasoning on top of that. This is also happening. Very similar stuff is happening in lots of other sports. Basketball was the very first. You could argue that baseball was first with Moneyball way back. But of these sports that move very quickly, where you need computer vision in order to generate the underlying raw data, basketball was first. Soccer came along. American football is also moving in this same direction. This is the way that sports is going overall, is this kind of reasoning that's based on collection of raw data that was impossible to collect before. So that provides a pretty good roadmap for where Pathr is going and where companies like us are going. So I think we can talk about what we're doing in retail and beyond. At a high level, the value proposition that Pathr brings forward is to take existing security cameras. So we leverage the infrastructure that's already in place, especially in retail. There are lots and lots of cameras. Just about every retailer has cameras throughout their store, mainly for loss prevention purposes. We leverage those camera feeds and we extract business insights from that. The way we do that is by applying spatial intelligence. So a little bit about how that tech stack operates. You're reading from left to right. So we start with sensor fusion. That's just bringing together various feeds. This is very commonly connecting to NVRs or connecting to cameras, bringing together lots of video feeds. We also ingest other feeds that might be able to give us information about where people are. And then the next step is location extraction. When we're talking about video feeds, this is person detection. And so this is something where we're leveraging OpenVINO very heavily. We're using person detectors from Open Model Zoo in some cases, where we're training our own detectors to detect other things beyond people or to detect people in different environments. But when we do that, we're able to optimize those detectors and those things that we've trained ourselves. We can optimize those in the OpenVINO environment so that we know that they'll run optimally and efficiently. And we layer in tracking on top of that. So we add a little bit of logic and some algorithmic magic in order to make sure that we're stringing those detections together so that we get comprehensive paths of people. And then we get to Pathr's behavior engine, which is really that dog brain that I mentioned before. You can think of that whole sensor layer as the alligator brain and the behavior engine as the dog brain. This is where we implement higher level reasoning so that we can extract business logic from what we're actually seeing. So these can be operational use cases based on tracking people around a queue and a checkout. Do you have the right number of checkouts open? It's going to be counting and entrance counting, or understanding the size of groups that come in. I'll give a couple more examples later, but this behavior engine really is the part that takes the raw underlying data, the locations of people over time, and extracts business value from that. And then our outbound data writer is just how you receive those results. You can receive those results via various dashboards and BI tools. You can receive those results in real time. This is really just an engineering component that takes the results of the behavior engine, the insights that it generates, and provides them to the stakeholders, to the folks that need them and care about them. So one of the things that we're most excited about with OpenVINO, especially in this latest release, is what's called the auto device plugin, or the auto plugin. And what this lets us do is to build one model and then deploy that model in various types of hardware. And so we'll look at a couple different types of hardware here, but in really any kind of hardware that comes in, OpenVINO is understanding the environment that it's running in, figuring out the most optimal and efficient way to run that model, and then running it so that we don't have to worry as much about the hardware, and we sure don't have to tailor the model to the hardware that it's going to run on. This is just a massive gain when you're a small startup like us. Every hour in the day matters. Every pair of hands typing code, it has a huge impact, and so we have to be as efficient as we possibly can. And so not retraining these models and not having to spend a lot of cycles figuring out where a particular model is going to run is just a massive gain for us as a business. It lets us do things like push a model to run on cameras, or if the cameras are not equipped or they're not able to run a particular person detection, we can just as easily move that same functionality into, say, the NVR, the piece of hardware that's recording the video. That NVR is not a piece of hardware that we control, so we don't know what that hardware environment will look like going in. But OpenVINO, as long as it's supported in that environment, will be able to disambiguate that, and we'll be able to take our models and run them efficiently. And then our base case is a server that we do control. But even in those cases, we want to be able to run the most optimal server. We want to be able to run as efficiently as we can. This is super important to our customers. And we also want to be able to support a heterogeneous environment. As much as we try to make every server exactly the same, it's just not realistic, especially when we have different size locations. We operate everywhere from tiny footprint luxury stores through shopping malls and office buildings that are hundreds of thousands of square feet. And so we need to be able to support lots of different types of hardware, and not having to change our software in order to support those different types of hardware is just huge for us. We want to be able to move that compute, especially the most heavyweight piece of compute, the person detection, the alligator brain compute, which is the hardest part computationally. We want to be able to move that around as efficiently and seamlessly and fluidly as possible. And so in this new release, this is one of the things that I've been excited about ever since I heard about it in the 2022.1 release, is this auto plugin. And this lets that happen with no developer involvement at all. So something that we're super excited about. We've been testing it. We love how it's working. So we're really excited about that. So now on to some examples of some of the more sophisticated stuff that we do. This is us tracking people as they move through a small specialty retailer. We're using 12 existing security cameras here. Our machine learning is able to segment into staff versus customers just based on the way the dots move around the map. So customers move differently. They go to different places than staff members. And then the machine learning picks out every instance of interaction between two people. with those pieces of information, it can figure out that this is a staff and customer interaction versus this is two customers interacting versus this is two staff members interacting. Quantify those, figure out where they happen, how long they took, and then be able to provide a visualization like this, which shows that staff and customers in this space are interacting most commonly towards the bottom right of the store, whereas the management would prefer they spend more time at the top left or the bottom left, where the higher margin items are. So this gives a real data-driven way, using machine learning and those vision primitives at the bottom of the stack to guide staff behavior. So management is excited about these kinds of things, and staff members also appreciate this because they're able to be more efficient and more optimal as well. So that's an example of how we do this staff and customer interaction analysis in one store. When we're doing this at scale, which is really what matters, the output looks oftentimes more like this. It's more plots and graphs, because we're not trying to do this in a one-off lab type environment. This is technology that's meant to scale across huge fleets of stores. We will be in tens of thousands of locations before we're done here. And so providing the data back to folks in a scalable way is really important to us. And the last example that I'll give is the system watching every shopper as they move through this space. This is that same specialty retailer. And what it's doing is assessing the behavior of each and every one of those customers in order to understand if one of those customers is doing something suspicious. Is somebody doing something out of the ordinary or something that we haven't seen before, possibly shoplifting or possibly doing something fraudulent or even dangerous? The system is able to pick out that behavior. Because these are just dots moving around a map, there's no PII associated with the dots whatsoever. The retailer or whoever is leveraging our platform is able to have the confidence in knowing that there's no risk of any violation of privacy or any bias whatsoever when they're making these sorts of assessments. And so where is this all heading? I mentioned that our vision is that spatial intelligence is operating in tens of thousands, if not hundreds of thousands, or even more locations worldwide. We certainly won't be the only player in the space. There are other folks doing similar stuff. We think we're the leaders, and we think that it's up to us to kind of lead this charge forward in order to bring this capability to every physical location. You wouldn't set up a website without attaching analytics to it, so you know what the visitors to that website are doing. And we feel that you also shouldn't set up a physical space. You shouldn't build a building without having some analytics attached to it, so you know what the visitors to that building are doing. One of the things that's really important to us, though, is that we are not able to do this alone. We know that we're a small startup, and we're very enthusiastic to work with the ecosystem, to not reinvent stuff that other people are already doing and that other folks are already working on. So we're working with big tech companies like Intel. We're working with startups like ourselves, small startups that have complementary skill sets. We're working with system integrators. We're working with distributors. We're really working within this ecosystem. I think that's a really important message for all of us, but in particular, startups that are smaller like Pathr. So to conclude, I showed a little bit of spatial intelligence, hopefully situated it in the broader technology landscape in computer vision. And then also mentioned, how OpenVINO 2022.1 is helping us to run faster. We can run more efficiently. We can run more optimally, which allows us to give better ROI to our customers. We pass those savings along. And ultimately, we hope that that's what's going to allow us to scale this capability to thousands and tens of thousands, even hundreds of thousands of locations. So please scan this QR code or take a photo of it, or it's actually available in the handouts if you'd like to get in touch with Pathr. And similarly, to learn more about OpenVINO, here's a QR code that you can either scan or photograph, or again, it's available in the handouts to be able to link out to OpenVINO. And with that, I'll stop. And I think we have about 5 minutes for questions, if there are any questions.
Yeah, thanks, George. We've got 2 questions that have come in so far. And the first one is, how many cameras can you process at the same time with Pathr?
In concept, that's unlimited. If you parallelize and you architect the system intelligently, but currently the most we're doing is a couple hundred cameras at a single time, and those are running in real time. We're doing that entirely on a single server. This is a pretty powerful server. It's got some big Xeon processors on board. but it's able to run a couple hundred cameras in real time, and then we can extract those results and provide those results back. This is a shopping mall that I'm describing that's got a couple hundred cameras in it.
Got it. Yeah. So since you brought it up, what hardware from Intel are you using? You mentioned Xeon. Can you tell us a little bit more about what hardware you're using?
So we're pretty focused on Xeon CPUs. That's most of what we're deploying are various shapes and sizes of Xeon CPUs. But we've also deployed a lot of NUCs. So we've got plenty of NUCs out in the field. But I think one of the things that's most interesting to us is, Intel is not standing still. Like, there's a lot of new stuff coming down the pipe. There's a lot of new development. There are new accelerators. There are new CPUs, integrated GPUs. There's just a lot of activity, and it's not realistic for us to keep tabs on all that activity and to go and new software accelerators that comes out. So that's really the promise of OpenVINO, and we're really seeing that promise come true. And that's one of the things that we're most excited about is we can kind of take our hands off of what accelerators are coming, and just when a new one comes along, have the confidence in knowing that our stuff will run on it.
Yeah, that's our goal. Write once, deploy anywhere. So I'm glad to hear that you feel that way. Another question that someone asked is, are the servers running at the edge or in the cloud? So you mentioned NUCs, so there's definitely some at the edge. Are you running anything in the cloud?
We're able to run either. We call ourselves deployment agnostic. We can run at the edge. We can run near the edge. There's lots of different compute architectures that we're able to support because of the way we've built our system. We do run in the cloud sometimes. This is typically when we're doing like a post hoc analysis or something like that. Almost all the time when we're running live, when we're producing real-time analytics, we're running on a server that's situated at the edge. So it's connecting directly to cameras. It's processing the feeds from those cameras, generating the analytics on-prem locally. Some of that is about latency. We don't want to have to make that round trip all the way back to the cloud, and bandwidth to move all that video out to the cloud, but as well as privacy. For GDPR, for example, you don't want to move video outside of the jurisdiction that it was created in. And the safest thing you can possibly do is to process the video locally on-prem where it was created, and then only take the anonymized results out of that location. And so various reasons, the short answer is we typically run on a server that's local.
Yeah, so you mentioned earlier the not having PII. So when you think about privacy, what are you doing to protect privacy of people shopping in a shopping mall?
Yeah, it's something that's really important to us. We talk a lot about that. We think that we're taking a very privacy forward stance. I think that we're leaders in the industry as far as that goes in terms of protecting consumer privacy. And the way we do that is actually very simple. We just don't collect personally identifiable information. We take video feeds, we turn those video feeds into anonymous dots moving around a map. Those dots have no age, gender, ethnicity, there's no facial recognition or any of those things. And then we generate all of the business insights that we need to generate just based on those dots and just based on how those dots move. So this means that we're GDPR and CCPA compliant right out of the box without doing anything. It also means that we're protecting consumer privacy in a way that other companies are just unable to do.
Cool. All right. Well, thanks, George. Thanks, Nicole, for doing the session with us today. And we look forward to the continued partnership with Pathr. It's really cool what you guys are doing.
Likewise. Thanks a lot, Ryan. Really appreciate you having us here.
Thank you.